Hello, this is the lecture for section 1.6, inverse functions. All right, starting at the beginning, we should define it. What is an inverse function? Well, in the most simplest terms, I would say an inverse function is one that undoes another function. Right? A more specific definition is here, listed here. It says if f of a equals b, then a function g of x is going to be the inverse of f if and only if g of b equals a. All right, we typically notate the inverse of a function with a -1 up where you might expect to find an exponent on some other number. Right, so when we see this function with a -1 up there, that reads f inverse of x. It does not mean raise that function to the negative first power. Right? All right, so what we're saying here is when we feed the input, when we feed an input, if a is the input, when we feed that into a function and we get an output b, right, we know that another function is in fact an inverse of that function if that output b gets fed into that inverse and we get back to the same original input. Or in other words, if I wanted to kind of make this a diagram, I might say something like this. All right, here's a function. It's my little function machine. Okay, we're going to call this function f. Okay, and we're going to feed into f, the inputs that are going to go into f, they're going to be values of x, right? The function f is going to do whatever it does to that value, and it's going to spit out a value for y, right? Now, if f has an inverse, and by the way, a function can only have an inverse if it's 1-to-1, okay? But we'll assume f is 1-to-1, so it's going to have an inverse. And if it's an inverse, let me see if I can draw another function machine here. Okay, here's the inverse of f, -1 up there. Yeah, f inverse. Okay, so if we feed that output of this function f into its inverse, okay, the inverse is going to spit out that original input, that original x. Right? So for example, say we have some function f, and say that function is, what it does is it says, take the input, multiply by 2. All right, so this function is going to be 2x. That's what that function is going to do. So if we feed a 2 into that function, or if x takes on the value of 2, then f of 2 is going to be 2 times 2, or 4, and the output, or the y here, is going to be 4, right? Well, if f inverse is, in fact, the inverse function of f, when I feed that 4 as an input to f inverse, or f inverse of 4, right, it's going to do the operation, whatever it would be, and what it's going to spit out, or the output, is going to be 2. Okay, so let's see, for this to happen, I guess the inverse function of x, of f, is going to be 1/2 x. 1/2 x, okay? So in other words, a function and its inverse swap domain and range. Look, the domain of a function, that's the set of all possible inputs to a function, right, is going to be the range of its inverse. Okay, and the range of a function, all its possible outputs, that's the range, is going to be, it's this guy's range, it's going to be the domain, it's going to be the domain of the inverse. Okay? So they swap their domain and range. All right, let's look at some examples.
In this video, I will demonstrate a process in which you can determine which type of statistical analysis
My computer's doing something that I want to stop.
The data you have collected, as well as the research design that you made.
There we go. Let's just continue on with this. All right, here's our example, an inverse function. If f of 3 equals 5, all right, find f inverse of 5. Right? What are we saying here? We're saying that, well, the input to f is 3, or the x is 3, right? And the output of f is 5, or the y is 5. So when we take that output and feed it into our inverse, right, or if the input to f inverse is 5, what does the output have to be? Well, it has to be the input of its function that it's the inverse of, right, or 3. Right? Conversely, if f inverse is negative 1, right, f inverse is negative 1, or I'm sorry, f inverse of negative 1, I should say, is 4, right? What is f of 4 going to be? Well, f of 4 is going to have to be negative 1, right? Because again, they swap x and y, or they swap their domain and range. All right? We can find the inverse of a function algebraically. Like if we have the algebraic representation of a function, we can find the inverse there, knowing that they swap domain and range, right? Or swap x's and y's, we can think about it this way. Okay, your textbook says this. I like to use this alternative method. I like to say, replace the function notation with y, or write that function just as an equation, y equals. Then switch your x and y. That's where their domain and range swap. Solve for y, because you have to solve for y to write function notation. Then you go ahead and write that as an inverse function in function notation. Now your textbook explains it this way. Your textbook says you could replace the function notation with y. You guys start there. Solve for x, then replace your x with your function notation. I don't know. I've always done it this way. So an interesting thing to note is that functions and their inverses undo each other, right? So if I compose the inverse of a function into the function, I will end up with the original input. If I compose a function into its inverse, I will end up with the original input, or x. Right? Let's take a look at a couple of examples. Let's find the inverse, right? And then let's check it by composing the inverse into the function and see if it ends up being just x. All right, so to find the inverse of this function, first let me write it as an equation. Y equals 2x plus 3. Okay, then let me swap my x and y. So then I'll say x equals 2y plus 3, and I need to solve for y. All right, so we'll subtract 3 from both sides. Excuse me, so 2y then is going to equal x minus 3. Let me come up here to finish. And if I divide everything by 2, I can then see that y is equal to x minus 3 divided by 2, right? Or I could write that as, let's say, 1/2 x minus 3/2. That's the same thing, right? So let me just put it in function notation now. The inverse, or f inverse of x, is 1/2 x minus 3/2. Okay, now, if I found the correct inverse here, or if I were to check my work here, I can go ahead and compose this inverse into the function, and I should end up with x, right? So, if it's true, f of its inverse, -1 of x, would equal x. So let's compose it and then find out. Let's find what f of 1/2 x minus 3/2 is. Well, let's see. The original function is 2x plus 3, so it's going to be 2 times its new input, 1/2 x minus 3/2, and then plus that 3. All right, well, if I distribute the 2, I get 2 times 1/2, or 1 times x, so that's just x. And 2 times negative 3/2, that's negative 2 times 3, or negative 6 divided by 2. That's just minus 3 plus 3. And look at that, the 3's add out. So it does in fact just equal x. Okay? Let's try it again. Look at g of x, 1 over x. All right? Let's find the inverse first. Let's make an equation. Y equals 1 over x. Okay, swap the x and y. X equals 1 over y. All right, solve for y. Let's see, I think I want to multiply both sides by y. So I'll get it out of the denominator. So then y times x equals 1. And solving for y means I'll have to divide both sides by x, right? So there's my equation. Y equals 1 over x. We'll just write that now as in function notation. So f inverse of x is 1 over x. Right? Let's check that. Let's compose them into each other and see if it actually ends up being x. Let's go the opposite way. Here we did f of f negative 1. If this is true, we can also say that f inverse, or f negative 1, of f of x also equals x. Let's try this one the opposite way, right? Let's try f inverse of f of x. So that's going to be f inverse of, what was f of x? Oh, it was just 1 over x. Oh, I switched over to f when we were doing g's. Oh, well. Make them g's. Okay? So I really want to find g of 1 over x. Let's see what that would be. That's going to be 1 over x, right, which is, of course, just x. All right, y is 1 over x. Well, 1, you think about that as 1 over 1 over x. That's really just a fraction divided by a fraction, right? So what do we do with that? We keep the top fraction, change the sign to multiplication, and flip the lower fraction. 1 times x over 1 times 1, of course, is just x. All right, that's it. So there is to inverse functions. And then lecture for inverse functions.